Hello. This is Pankaj Edu-Tech YouTube channel. Please like, share and subscribe. Open description box and find the URL of the website and visit the website and subscribe the website by your email to update about new educational video and updated information about computer science and information technology through blogs. We provide kids learning video for all the subject and as per request of the audience and subscribers. We teach basics of computers programming language such as Python, Numpy, Panda, information technology, web designing, blog publishing, and educational course and content designing. We also help for developing website for the customers, creating YouTube channel and training for video creation, editing and publishing and advertising. Please fill the registration for available on our website and place your requirement. Thank you very much for watching the video.
Everybody, today you are going to learn a very important topic, that is chapter 3, dictionaries. Dictionaries is our today's topic. After studying this lesson, the students will be able to, it means you will able to learn and understand the need of dictionary, solve problems by using dictionaries, get clear idea about dictionaries functions, and understand the difference between list and dictionary. First of all, we will discuss what is a dictionary. A dictionary is like a list, but more in general. In a list, index value is an integer, while in a dictionary, index value can be any other data type and are called keys. The key will be used as string as it is easy to recall. A dictionary is an extremely useful data storage construct for sorting, storing and retrieving all key value pairs where each element is accessed or indexed by a unique key. However, dictionary keys are not in sequence and hence maintain no left to right order. Key value pair. We can refer to a dictionary as a mapping between a set of indices, which are called keys, and a set of values. Each key maps a value. This association of a key and a value is called a key value pair. Syntax. My dictionary, key 1 value 1, key 2 value 2, key 3 value 3, key n value n. Here is an important point. Note, dictionary is created by using curly brackets. This point should be noted. When you declare a dictionary, you should use curly bracket only. Let's take one example. A is equal to one, its value is 1, 2, 2, 3, 3. 1, 2, 3 digits are key and words 1, 2, 3 are their value. Print A. Dictionary is printed 1, 2 and 3. In the above example, we have created a list that maps from numbers to English words. So the keys values are in numbers and values are in strings. A is equal to key values are 1, 2, 3 and their values are 1, 2, 3 in words. Map between keys and values. Let's take one example. Computer, it is a dictionary. Input, keyboard, output, mouse, language, Python, OS, Windows 8. Print computer. Computer is a dictionary. So what is printed? Input, keyboard, OS, Windows 8, language, Python, output, mouse. In the above example, we have created a list that maps from computer related things with example. So here the keys and values are in strings. The order of the key value pairs is not in same order, that is input and output. Orders are not same. We can get different order of items in different computers. Thus, the order of items in a dictionary is unpredictable. Example: D is equal to sun, Sunday, MON Monday, TUE Tuesday, Wednesday, Thursday, Friday, Saturday. Print D. Wednesday, Sunday, Thursday, Tuesday, Monday, Friday and Saturday. Creation, initializing and accessing the elements in a dictionary. The function dictionary is used to create a new dictionary with no items. This function is called built-in functions. We can also create dictionary using curly bracket. D, dictionary function is called and it is assigned to D. Print D. So what is the output? Curly bracket. Why? Because there is no elements. Curly bracket represents empty string to add an item to the dictionary. Empty string, we can use square brackets for accessing and initializing dictionary values. Example: H equal to dictionary function. It means a dictionary is assigned to a variable H. Capital H1 is equal to keyboard. H2 equal to mouse. H3 equal to printer. H4 equal to scanner. Print H4 scanner, 3 printer, 2 mouse, 1 keyboard. It is the output. Traversing a dictionary. Let us visit each element of the dictionary to display its values on screen. This can be done by using for loop. Example code: H equal to 4 scanner, 3 printer, 2 mouse, 1 keyboard. For I in H, print I. semicolon HI. So what is the output? 4 scanner, 1 keyboard, 3 printer, 2 mouse. Or code H equal to 4 scanner, 3 printer, 2 mouse, 1 keyboard. Print I value /t hi value. For I in H, print I /t hi. I value hi value 4 scanner 1 keyboard 3 printer 2 mouse. As said previously, the order of items in a dictionary is unpredictable. Creating initializing values during runtime dynamic allocation, we can create a dictionary during runtime also by using dictionary function. This way of creation is called dynamic allocation because during the runtime memory keys and values are added to the dictionary. Example, I write a program to input total number of sections and class teachers name in 11th class and display all information on the output screen. Code class xi equal to dictionary function n equal to input enter total number of section in 11 class I is equal to 1 while I less equal n is equal to raw input enter section. B is equal to raw input enter class teacher name. Class 11 A is equal to B. I is equal to I plus 1 print class /t section /t teacher name. For I in class 11 print 11 /t I /t class xi I or 11i. Look at the output. Enter total number of sections in class 11. Class 3 enter section A. Enter class teacher name Lena. Enter section B. Enter class teacher name Madhu. Enter section C. Enter class teacher name Surpreet. Class section teacher name 11A Lena, 11C Surpreet, 11B Madhu. Appending values to the dictionary, we can add new elements to the existing dictionary, extend it with single pair of values, or join two dictionaries into one. If we want to add only one element to the dictionary, then we should use the following method. Syntax: dictionary name key equal to value. Example: A is equal to Monday, Tuesday, Wednesday. A Thursday equal to Thursday. Separate values assigned in this statement. Print A THU Thursday, WD Wednesday, MON Monday, TUE Tuesday. Merging dictionaries and update function. Two dictionaries can be merged in one by using update function method. It merges the keys and values of one dictionary into another and overrides values of the same key. Syntax: dictionary name 1 dot update dictionary name 2. Using this dictionary name 2 is added with dictionary name 1. Example, D1 is equal to 1 ratio 10, 2 ratio 20, 3 ratio 30. D2 equal to 4 ratio 40, 5 ratio 50, or you can read 5 colon 50. First one is the key and second is value. D1 dot update D2. Print D1 1, 10, 220, 330, 440, 550. D1 is updated by D2. So both the elements of dictionary 1 and dictionary 2 are now merged. Example, A10, 230, 330, 540, 660. K, D1 is equal to 110, 220, 330. Key 2 value is 20. D2 equal to 230, 540, 660. Key 2 value 30. D1 dot update D2. Print D1. 2 value is replaced by 30 in D1. Here is 230, here is also 230. So students, you will learn removing an item from dictionary. This topic you will learn in my upcoming video. So you need to like the video, share the video and subscribe the channel so that you can get notification of my upcoming video. Open the description box and find the URL of the website. Visit the website and find out the important information and read it. Subscribe the website by putting your email ID and subscribe button. You will get the notification of my upcoming blogs, and whatever the blogs are posted previously, you need to read it and update with the technology, and you will get the notification, sample papers, question papers, test papers, marking schemes, etc. when it is uploaded on the website if you subscribe the website. Thank you very much. Now you are going to learn removing an item from dictionary. We can remove item from the existing dictionary by using del keyword. Syntax: its syntax is del dictionary name key. For example, A is equal to MON Monday, TUE Tuesday, WED Wednesday, THU Thursday. So there is a delete statement, delete from A, Tuesday. So this Tuesday member will be deleted from the dictionary. Now if we give a print command, see, Thursday, Wednesday, Monday is there, but you are not seeing Tuesday. Dictionary functions and methods. First function you are going to learn, it is CMP function. This is used to check whether the given dictionaries are same or not. If both are same, it will return 0, otherwise return 1 or -1. If the first dictionary having more number of items then it will return 1, otherwise return -1. Look at the syntax. CMP dictionary 1 and dictionary 2 returns 0 or 1 or -1. Dictionary 1 and dictionary 2 are dictionary. For example, D1 Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. There is another dictionary D2. It has Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. D3 Monday, Tuesday, Wednesday. Then we compare D1 and D3 using CMP function. Then what is the output? Is 1. It means D1 D2 are equal. Both are equal. CMP D1 D2 both are equal, then it returns 0. And CMP D3 D1 not equal, so it returns -1. I hope the topic whatever discussed today you have understood. In my next class I will teach len function. So you need to subscribe the channel so that you can get the notification when video is uploaded. You need to like the video and share the video with your friends so that your friends can also learn Python, computer science or information practice free classes. Thank you very much for watching the video. Everybody, today I am going to teach chapter 6, Introduction to Numpy. In this chapter you will learn introduction of Numpy array, indexing and slicing, operations on arrays, concatenating arrays, reshaping arrays, splitting arrays, statistical operations on arrays, loading arrays from files, saving Numpy arrays in files on disk. The goal is to turn data into information and information into data. Carly Fiorina. This is a very important thought. You keep it in mind. I repeat it. The goal is to turn data into information and information into insight. Carly Fiorina. This was a very important thought. Introduction. Numpy stands for Numerical Python. Numpy stands for Numerical Python. It is a package for data analysis and scientific computing with Python. Numpy uses a multidimensional array object and has functions and tools for working with these arrays. The powerful n-dimensional array in Numpy speeds up data processing Numpy can be easily interfaced with other Python packages and provides tools for integrating with other programming languages like C, C++, etc. Installing Numpy. Numpy can be installed by typing following commands: pip install numpy. Array. We have learned about various data types like list, tuple, and dictionary. In this chapter, we will discuss another data type, array. An array is a data type used to store multiple values using a single identifier variable name. An array contains an ordered collection of data elements where each element is of the same type and can be referenced by its index position. The important characteristics of an array are: each element of the array is of same data type, though the values stored in them may be different. The entire array is stored continuously in memory. This makes operation on array fast. Each element of the array is identified or referred using the name of the array along with the index of that element, which is unique for each element. The index of an element is an integral value associated with the element based on the element position in the array. For example, consider an array with 5 numbers: 10, 9, 99, 71, 90. Here the first value in the array is 10 and has the index value 0 associated with it. The second value in the array is 9 and has the index value 1 associated with it, and so on. The last value, in this case the fifth value in this array, has an index 4. This is called zero based indexing. This is very similar to the indexing of list. In Python, the idea of arrays is to important that almost all programming languages support it in one form or another. Contiguous memory allocation. The memory space must be divided into the find size position, and each position is allocated to a single data only. Now, contiguous memory allocation. Divide the data into several blocks and place in different parts of the memory according to the availability of memory space, but commonly known as array. In rest of the chapter, we will be referring to Numpy array whenever you use array. Following are few differences between list and array. Difference between list and array. List can have elements of different data types. For example, 1 3.4 hello a important array. All elements of an array are of same data type. For example, an array of floats may be 1.2, 5.4, 2.7. Elements Elements of a list are not stored contiguously in memory. Array elements are stored in contiguous memory location. This makes operation on arrays faster than lists. Lists do not support element-wise operation, for example addition, multiplication, etc., because elements may not be of same type. Arrays support element-wise operations. For example, of A1 is an array, it is possible to say A1 divided by 3 to divide each element of the array by 3. List can contain objects of different data type that Python must store the type information for every element along with its element value. Thus, lists take more space in memory and are less efficient. Arrays support element-wise operation. For example, A1 is an array. It is possible to say A1 divided by 3 to divide each element of the array by 3. Numpy array takes up less space in memory as compared to a list because arrays do not require to store data type or each element separately. List is a part of core Python. Array ND array is a part of NumPy library. Creation of Numpy arrays from list. There are several ways to create arrays. To create an array and to use its methods, first we need to import the NumPy library. NumPy is loaded as np. We can assign any name. NumPy must be written in lowercase. See the syntax. Import NumPy as np. Import NumPy as np. The NumPy array function converts a given list into an array. For example, create an array called array1 from the given list. Array1 np.array 10, 20, 30. Display the contents of the array. Array1. Array 10, 20, 30. Creating a 1D array. An array with only single row of elements is called 1D array. Let us try to create a 1D array from a list which contains numbers as well as strings. Array2 np.array 5 minus 7.4 a 7.2 array 2. array 5 minus 7.4 a 7.2 d type equal to u32. A common mistake occurs while passing argument to array function. If we forget to put square brackets, make sure only a single argument containing list of values is passed. Incorrect way is equal to np dot array parenthesis 1 2 3 4 parenthesis. Has correct way is equal to np dot array 1 2 3 4. So where is the mistake? Just find out. Here is the mistake. Parenthesis is wrong. You should use square bracket. Square bracket is right. Observe that since there is a string value in the list, all integers and float values have been promoted to string while converting the list to array. Note, U32 means Unicode 32 data type. Creating a 2D array. We can create a two-dimensional 2D array by passing nested lists to the array function. Example 6.1. Array 3 equal to np dot array 2.4, 3, 4.91, 7, 0, minus 1. Array 3, array 2.4, 3, 4.91, 7 0 point, minus 1 point. Observe that the integers 3, 7, 0 and minus 1 have been promoted to floats. Here take care of these numbers. These are promoted to float. Attributes to NumPy array. Some important attributes of a NumPy and array object are end array dot ndim gives the number of dimensions of the array as an integer value. Array can be one-dimensional, two-dimensional or n-dimensional. In this chapter we shall focus on one-dimensional and two-dimensional arrays only. Numpy calls the dimensions as axes, plural of axes. Thus a two-dimensional array has two axes. The row axis is called axis 0 and the column axis is called axis 1. The number of axes is also called the array's rank. A list is called nested list when each element is a list itself. Example 6.2. Let's start. Array 1 dot ndim output 1. Array 3 dot ndim output is 2. ndarray dot shape, it gives the sequence of integers indicating the size of the array for each dimension. Example 6.3. Array 1 is 1D array, there is nothing after in sequence. Array 1 dot save 3, array 2 dot save 4, array 3 dot save 3 2. The output 3 2 means array 3 has 3 rows and 2 columns. ND array dot size, it gives the total number of elements of the array. This is equal to the product of the elements of shape. Example 6.4, array 1 dot size 3, array 3 dot size 6. ND array dot data type or D type is the data type of the elements of the array. All the elements of an array are of same data type. Common data types are int 32, int 64, float 32, float 64, u32, etc. Example 6.5, array 1 dot d type int 32, array 2 dot d type u32, array 3 dot d type float 64. ND array dot item size, it specifies the size in bytes of each element of the array. Data type int32 and float32 means each element of the array occupies 32 bits in memory, 8 bits from a byte. Thus an array of elements of type in 32 has item size 32 divided 4 bytes. Likewise, int 64, float 64 means each item has item size 64 divided by 8 equal to 8 bytes. Array 1 dot item size 4, memory allocated to integer. Array 2 dot item size has memory allocated to string. Array 3 dot item size, memory allocated to float type. Other ways of creating Numpy arrays. We can specify data type, integer, float, etc. while creating array using D type as an argument to array function. This will convert the data automatically to the mentioned type. In the following example, nested list of integers are passed to the array function. Since data type has been declared as float, the integers are converted to floating point numbers. Array 4, np.array 1 2 3 4 d type equal to float. Array 4, array 1 dot 2 dot 3 dot 4 dot we can create an array with all elements initialized to 0 using the function zeros. By default, the data type of the array created by zeros is float. The following code will create an array with 3 rows and 4 columns with each element set to 0. Array 5 is equal to np.zeros34. Array 5 array 0.0.0. We can create an array with all elements initialized to 1 using the function ones. By default, the data type of the array created by ones is float. The following code will create an array with 3 rows and 2 columns. Array 6 np.ones32. Array 6 array 1.1.1.1.1.1. We can create an array with numbers in a given range and sequence using the arrange function. This function is analogous to the range function of Python. Array 7 equal to np.arrange6. An array of 6 elements is created with start value 5 and step size 1. Array 7 array 0 1 2 3 4 5. Creating an array with start value. Today I am going to teach slicing. Sometimes we may need to extract a part of a series. This can be done through slicing. This is similar to slicing used with Numpy arrays. We can define which part of the series is to be sliced by specifying the start and end parameters, start end, with the series name. When we use positional indices for slicing, the value at the end index position is excluded, that is only end start. Number of data values of the series are extracted. Consider the following series cap country. Series cap country pd.series New Delhi, Washington, London, Paris, index India, USA, UK, France. Series cap country 1:3 excludes the value at index position 3. USA, Washington, UK, London. D-type object. As we can see that in the above output, only data values at indices 1 and 2 are displayed. If labeled indexes are used for slicing, then value at the end index label is also included in the output. For example, series cap country USA, France, USA, Washington DC, UK, London, France, Paris. D-type object. We can also get the series in reverse order. For example, series cap country -1, France, Paris, UK, London, USA, Washington DC, India, New Delhi. D-type object. We can also use slicing to modify the values of series elements as shown in the following example. import numpy as np, series alf equal to pd.series np.arrange 10, 16, 1, index a, b, c, d, e, f. Series alf a, b, c, d, e, f. 10, 11, 12, 13, 14, 15. Series alf 1, 2, 3, 50. Series alf A, B, C, D, E, F up to 50. So 10, 50, 50, 13, 14, 15. D type int 32. Observe that updating the values in a series using slicing also excludes the value at the end index position, but it changes the value at the end index label when slicing is done using labels. Series alf CE 500, series alf A, B, C, D, E, F 10, 50, 500, 500, 500 and 15. So in position of CE, what is assigned? 500. Next, attribute of series. We can access certain properties called attributes of a series by using that property with the series name. Table 2.1 lists some attributes of pandas series using series cap country as an example. Series cap country India, New Delhi, USA, Washington DC, UK, London, France, Paris. Dtype object. Attributes of pandas series. Attribute name, name. Purpose, assigns a name to the series. Example, series cap country dot name capitals. Print, series cap country India, New Delhi, USA, Washington DC, UK, London, France, Paris. Name capitals. Dtype object. Index.name assigns a name to the index of the series. Series cap country dot index dot name is equal to countries. Print, series cap country countries India, New Delhi, USA, Washington DC, UK, London, France, Paris. Name capitals. Dtype object. Values, prints a list of the values in the series. Print, series cap country values New Delhi, Washington, London, Paris. Size, prints the number of values in the series object. Print, series cap country dot size 4. Empty, prints true if the series is empty and false otherwise. Series cap country empty false. Create an empty series. Series empty pd.series function. Series empty dot empty function. It is true. Method of series. In this section we are going to discuss some of the methods that are available for pandas series. Let us consider the following series. Series 1020 pd.series np.arrange 10, 21. Print, series 1020 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So activity 2.3, consider the following code. Import pandas as pd, import numpy as np, s2.pd.series. 12 NP nan 10 print S2. Find out output of the above code and write a Python statement to count and display only non-null values in the above series. Method: head n explanation returns the first n members of the series. If the value for n is not passed, then by default n takes 5 and the first 5 members are displayed. Series 1020.head 2 0 1 10 11 dtype int32. Series 1020.head function 10 11 12 13 14 dtype int32. Count function returns the number of non-null values in the series. Series 1020.count function 10 tail n returns the last n members of the series. If the value for n is not passed, then by default takes 5 and the last 5 members are displayed. Series 1020.tail2 8 9 18 19 dtype int32. Series 1020.tail function 5 6 7 8 9 15 16 17 18 19 dtype int32. Mathematical operators on series. We have learned in class 11 that if we perform basic mathematical operations like addition, subtraction, multiplication, division, etc. on two NumPy arrays, the operation is done on each corresponding pair of elements. Similarly, we can perform mathematical operations on two series in pandas. While performing mathematical operations on series, index matching is implemented and all missing values are filled in with NaN by default. Consider the following series A and B for understanding mathematical operation on series in pandas. Series A equal to pd.series 1 2 3 4 5, index equal to A B C D E. So index is printed here A B C D E, and this is the series 1 2 3 4 5, and that data type is int64. Series B pd.series 10 20 minus 10 minus 50 minus 100 is assigned, and what is the index? Z Y A C E. Series B is printed here Z Y A C E, and what are the values? 10 20 minus 10 minus 50 and 100. So in the next class I will teach addition of two series. So subscribe the channel so that you can get the notification when videos are uploaded. Like the video and share the video with your friends so that they can also learn NumPy and Panda and Python programming. Thank you very much. Start. Attribute of series. This is the topic we are going to cover. Attributes of series. We can access certain properties called attributes of a series by using that property with the series name. Table 2.1 lists some attributes of Panda series under using series cap country as an example. Series cap country: India, New Delhi, USA, Washington, UK, London, France, Paris, and data type object. Name assigns a name to the series. Example, series capcountry.name capitals. Print series cap country India, New Delhi, USA, Washington DC, UK, London. Frame France, Paris. Name capitals. Dtype object. Index.name assigns a name to the index of the series. Series capcountry.index.name is equal to countries. Print series cap country countries India, New Delhi, USA, Washington, UK, London, France, Paris. Name capitals. Dtype object. Values prints a list of the values in the series. Print series capcountry.values New Delhi, Washington, London, Paris. Size prints the number of values in the series object. Print series capcountry.size 4. Empty prints true if the series is empty and false otherwise. Series capcountry.empty false. Create an empty series. Series empty pd.series function. Series empty.empty true. Activity 2.3 considers the following code. Import pandas as pd, import numpy as np, s2 dot equal to pd dot series 12 np nan, print s2. Find output of the above code and write a Python statement to count and display only non-null values in the above series. In this section we are going to discuss some of the methods that are available for pandas series. Let us consider the following series. Series 1020 pd.series np.arrange 1021. Print series 1020 10 11 12 13 14 15 16 17 18 19. Method head n explanation returns the first n members of the series. If the value for n is not passed, then by default n makes 5 and the first 5 members are displayed. Series 1020.head to 0 10 1 11. Dtype int 32. Series 1020.head function 0 1 2 3 4 10 11 12 13 14. Tail n returns the last n members of the series. If the value for n is not passed, then by default n takes 5 and the last 5 members are displayed. Series 1020.tail to 8 9 18 19. Dtype int 32. Series 1020.tail function 5 6 7 8 9 15 16 17 18 19. Mathematical operation on series. We have learned in class 11 that if we perform basic mathematical operations like addition, subtraction, multiplication, division, etc. on two numpy arrays, the operation is done on each corresponding pair of elements. Similarly, we can perform mathematical operation on two series in pandas. While performing mathematical operation on series, index matching is implemented and all missing values are filled in with NaN by default. Consider the following series, series A and series B, for understanding mathematical operations on series in pandas. Series A equal to pd dot series 1 2 3 4 5. Index is equal to A B C D E. Series A B C D E 1 2 3 4 5 in 64. Series B pd dot series 10 20 minus 10 minus 50 minus 100. Index ZYACE. Series B ZYACE 10 20 minus 10 minus 50 100 in 64. Addition of two series. It can be done in two ways. In the first method, two series are simply added together as shown in the following code. table 2.2 shows the detailed values that were matched while performing the addition. Note here that the output of addition is none if one of the elements or both elements have no value. Series A plus series B minus 9.0 none, minus 47.0 none, 105.0 none, none. Float 64. Table 2.2 details of addition of two series index A, B, C, D, E, Y, Z. Value from series A 1, 2, 3, 4, 5. Value from series B minus 10, minus 50, 100, 20, 10. Series A plus series B minus 9.0 NaN minus 47.0 NaN 105 NaN NaN. The second method is applied when we do not want to have NaN values in the output. We can use the series method add function and parameter fill value to replace missing value with a specified value, that is calling series A dot add series B is equivalent to calling series A plus series B, but add function allows explicit specification of the fill value for any element in series A or series B that might be missing as shown in table 2.3. Series A dot add series B fill value 0, minus 9.0, 2.0, minus 47, 4.0, and 5.0, 20.0, 10.0. Draw two tables for subtraction similar to table 2.2 and 2.3, showing the changes in the series elements and corresponding output without replacing the missing values, and after replacing the missing value with 1000. Index A, B, C, D, E, Y, Z. Value from series 1 to 5 and then 0. Value from series B minus 10, 0, minus 50, 0, 100, 20, 10. Series A plus series B minus 9.0, 2.0, minus 47, 4.0, 1 and 5, 20, 10. Note that table 2.2 shows the changes in the series elements and corresponding output without replacing the missing values, while table 2.3 shows the changes in the series elements and corresponding output after replacing missing values by 0. Just like addition, subtraction, multiplication and division can also be done using corresponding mathematical operators or explicitly calling of the appropriate method. Subtraction of two series. Again, it can be done in two different ways as shown in the following examples. Series A minus series B has using subtraction operator 11.0 nan, 53.0 nan, minus 95.0 nan, nan. D type float 64. Activity 2.5. Draw two tables for multiplication similar to table 2.2 and 2.3, showing the changes in the series elements and corresponding output without replacing the missing values and after replacing the missing values with 0. Let us now replace the missing values with 1000 before subtracting series B from series A using explicit subtraction method subfunction. Series A dot sub series B fill value 1000 using fill value 1000 while making explicit call of the method 11.0 minus 998.0 53.0 minus 996.0 minus 95.0 980.0 990.0. Data type float 64. Multiplication of two series. Multiplication of two series. Again, it can be done in two different ways as shown in the following example. Series A, series B using multiplication operator. A minus 10.0, B NaN, C minus 150.0, D NaN, E 500, Y NaN, Z NaN. D type float 64. Let us now replace the missing value with 0 before multiplication of series B. with series A using explicit multiplication method, MUL function. Activity 2.0, draw two tables for division similar to table 2.2 and 2.3, showing the changes in the series elements and corresponding output without replacing the missing value and after replacing the missing values with 0. Series A find MUL. Series B fill value 0. Using fill value 0 while making explicit call of the method -10.0, 0.0, -150.0, 0.0, 500.0, 0.0, 0.0, data type float 64. Division of two series. Again, it can be done in two different ways as shown in the following example. Series A, series B using division operator -0.1.0 nan -0.06 nan. Explicit call to a mathematical operation is preferred when series may have missing values and we want to replace it by a specific values to have a concrete output in place of nan. E 0.05, Y NaN, Z NaN, data type float 64. Let us now replace the missing values with 0 before dividing series A by series B using explicit division method, division function. Using fill value 0 while making explicit call of the method A -0.10 D enough C -0.06 D enough E 0.05 Y 0.00 Z 0.00 D type float 64. Data frame. Sometimes we need to work on multiple columns at a time. That is, we need to process the tabular data. For example, the result of a class, items in a restaurant's menu, reservation chart of a train. Pandas store such tabular data using a data frame. A data frame is a two-dimensional labeled data structure like a table of MySQL. It contains rows and columns and therefore has been a row and column index. Each column can have a different type of value such as numeric, string, boolean, etc. as in tables of a database. Column indexes. Row indexes. State 1 Assam, 2 Delhi, 3rd Kerala. Geographical area square kilometer. Area under very dense forest square kilometer. Creation of data frame. There are a number of ways to create a data frame. Some of them are listed in this section. Creation of an empty data frame. An empty data frame can be created as follows. Import pandas hpd d frame emt equal to pd.dataframe function d frame emt empty data frame columns index. Think and reflect. What would happen if we pass 3 columns or 5 columns instead of 4 in the above code function? What is the reason? Creation of data frame from Numpy and arrays. Consider the following 3 Numpy and arrays. Let us create a simple data frame without any column labels using a single ND array. Import numpy as np array1 equal to np.array 10 20 30 array2 np.array 100 200 300 array3 np.array -10 -20 -30 -40. D frame 4 pd.dataframe array1 D frame 4 0, 1, 10, 120, 230. We can create a data frame using more than one ND arrays as shown in the following example. D frame 5 equal to period dot data frame array 1, array 3, array 2, columns A, B, C, D. D frame 5 A, B, C, D 0, 1, 2, 10, 20, 30, NAN, minus 10, minus 20, minus 30, minus 40, 100, 200, 300, NAN. Creation of data frame from list of dictionaries. We can create data frame from a list of dictionaries. For example, has create list of dictionaries. List dictionary A10, B20, A5, B10, C20. D frame list dictionary equal to PD dot data frame list dictionary D frame list dictionary A, B, C 0, 1, 10, 20, NAN 5, 10, 20.0. Here the dictionary keys are taken as column labels and the values corresponding to each key are taken as rows. There will be as many rows as the number of dictionaries present in the list. In the above example, there are 2 dictionaries in the list. So the data frame consists of 2 rows, number of columns. In a data frame is equal to the maximum number of keys in any dictionary of the list. Hence there are 3 columns as the second dictionary has 3 elements. Also note that NaN, not a number, is inserted if a corresponding value for a column is missing. Creation of data frame from dictionary of lists. Data frames can also be created from a dictionary of lists. Consider the following dictionary consisting of the keys, state, G area, geographical area and VDF, very dense forest, and the corresponding values as list. Dense forest, state, Assam, Delhi, Kerala. Geographical area, these 3, VDF, these 3 values are there. D frame forest equal to PD dot data frame dictionary forest D frame forest, then state, geographical area, VDF 0, 1, 2. Note that dictionary keys become column labels by default in a data frame and the list becomes the rows. Thus a data frame can be thought of as a dictionary of list of a dictionary of series. We can change the sequence of columns in a data frame. This can be done by assigning a particular sequence of the dictionary keys as columns parameters. For example, D frame forest 1 PD dot data frame dictionary forest columns state VDF G area. D frame forest 1 state VDF G area 0, 1, 2 Assam, Delhi, Kerala. VDF and G area is printed. In the output, VDF is now displayed as the middle column instead of last. Creation of data frame from series. Consider the following 3 series. Series A, PD dot series 1, 2, 3, 4, 5, index A, B, C, D, E. Series B, PD dot series 1000 to 2000 minus 1000 minus 5000 minus 1000, index A, B, C, D, E. Series C equal to PD dot series 10, 20 minus 10, minus 50, minus 100. Index ZYACE. We can create a data frame using a single series as shown below. D frame 6 PD data frame series A. D frame 6 A B C D E 0 1 2 3 4 5. Here the data frame 6 has many numbers of rows as the numbers of elements in the series, but has only one column. To create a data frame using more than one series, we need to pass multiple series in the list as shown below. D frame 7 PD data frame series A series B. D frame 7 A B C D E 0 1 2 3 4 5 1 1000 2000 minus 1000 minus 5000 1000. Observe that the labels in the series object become the column name in the data frame object, and each series becomes a row in the data frame. Now look at the following example. D frame 8 PD data frame series A series C. D frame 8 A B C D E Z Y 0 1.0 2.0 3.0 4.0 5.0 NaN 1 minus 10.0 NaN minus 50.0 NaN 100.0 10.0 20.0. Here different series do not have the same set of labels, but the number of columns in a data frame equals to distinct labels in all the series. So if a particular series does not have a corresponding value for a label, NaN is inserted in the data frame columns. Creation of data frame from dictionary of series. A dictionary of series can also be used to create a data frame. For example, result sheet is a dictionary of series containing marks of 5 students in 3 subjects. The names of the students are the keys to the dictionary, and the index values of the series are the subject names as shown below. Result sheet Arnab PD series 90 91 97 index maths science Hindi. Ramit PD series 92 81 96 index maths science Hindi. Samriddhi PD series 89 91 88 index maths science Hindi. Riya PD series 81 71 67 index maths science Hindi. Mallika PD series 94 95 99 index maths science Hindi. Result DF equal to PD data frame result sheet. Result DF Arnab Ramit Samriddhi Riya Mallika. Maths 90 92 89 81 94. Science 91 81 91 71 95. Hindi 97 96 88 97 67 99. The following output shows the every column in the data frame is a series. Type result df.arnab class pandas.core.series. When a data frame is created from a dictionary of series, the resulting index of row labels are a union of all series indexes used to create the data frame. For example, dictionary for union equal to series 1, PD dot series 1 2 3 4 5, index equal to A B C D E, series 2, PD dot series 10 20 minus 10 minus 50 minus 100, index Z Y A C E, series 3, PD dot series 10 20 minus 10 minus 50 100, index equal to Z Y A C E. D frame union. D frame union, PD dot data frame dictionary function union. D frame union, series 1, series 2, series 3, A B C D E Y Z, 1.0 2.0 3.0 4.0 5.0 NaN, series 2, minus 10.0 NaN, minus 50.0 NaN, 100.0 20.0 10.0, series 3. So I will teach you in my next class operation on rows and columns in data frames. So like the video, share the video with your friends so that they can freely learn Python programming, Numpy and Pandas. Thank you very much for watching the video. Hello everybody. Today I am going to teach chapter 2, data handling using Panda 1. If you don't think carefully, you might believe that programming is just typing statements in a programming language. W. Cunningham. This is a very important thought. Programming is not only typing the statements, but it is a logic of your brain. In this chapter, what you are going to learn: introduction to Python libraries, series, data frame, importing and exporting data between CSV files and data frames, Pandas series versus Numpy and array. Introduction to Python libraries. Python libraries contain a collection of built-in modules that allow us to perform many actions without writing detailed programs for it. Each library in Python contains a large number of modules that one can import and use. Numpy, Pandas and Matplotlib are three well-established Python libraries for scientific and analytical use. These libraries allow us to manipulate, transform, and visualize data easily and efficiently. Numpy, which stands for Numerical Python, is a library we discussed in class 11. Recall that it is a package that can be used for numerical data analysis and scientific computing. Numpy uses a multidimensional array object and has functions and tools for working with these arrays. Elements of an array stay together in memory, hence they can be quickly accessed. Pandas pan E1 data. Pan E1 data is a high level data manipulation. high-level data manipulation tool used for analyzing data. It is very easy to import and export data using Pandas library, which has a very rich set of functions. It is built on packages like Numpy and Matplotlib and gives us a single convenient place to do most of our data analysis and visualization work. Panda has three important data structures, namely series, data frame, and panel, to make the process of analyzing data organized, effective, and efficient. The Matplotlib library in Python is used for plotting graphs and visualizing. Using Matplotlib with just a few lines of code, we can generate publications, quality plots, histograms, bar charts, scatter plots, etc. It is also built on Numpy and is designed to work well with Numpy and Pandas. You may think what the need for Pandas is when Numpy can be used for data analysis. Following are some of the difference between Pandas and Numpy. A Numpy array requires homogeneous data, while a Panda data frame can have different data types: float, int, string, date, time, etc. Panda have a simpler interface for operations like file loading, plotting, selection, joining, group by, which come very handy in data processing applications. Panda data frames with column names make it very easy to keep track of data. Panda is used when data is in tabular format, whereas Numpy is used for numeric array based data manipulation. Installing Pandas is very similar to initializing Numpy. To install Panda from command line, we need to type in pip install pandas. Pip install panda. Note that both Numpy and Pandas can be installed only when Python is already installed on that system. The same is true for other libraries of Python. Data structure in Pandas. A data structure is a collection of data, values, and operations that can be applied to that data. It enables efficient storage, retrieval, and modification to the data. For example, we have already worked with a data structure ND array in Numpy in class 11. Recall the age with which we can store, access, and update data using a Numpy array. Two commonly used data structure in Pandas that we will cover in this book are series, data frames. What are series? A series is a one-dimensional array containing a sequence of values of any data type: int, float, list, string, etc., which by default have numeric data labels starting from 0. The data label associated with a particular value is called its index. We can also assign values of other data types as index. We can imagine a pandas series as a column in a spreadsheet. Example of a series containing names of students is given below. Index value 0 Arnab, 1 Samriddhi, 2 Ramit, 3 Divyam and 4 Kritika. Creation of series. There are different ways in which a series can be created in pandas. To create or use series, we first need to import the pandas library. Creation of series from scalar values. A series can be created using scalar values as shown in the example below. Import pandas as PD. Import pandas with alias PD. Series 1 equal to PD dot series 10, 20, 30. Create a series. Print series 1. Display the series. Output 0, 1, 2, 10, 20, 30. D type int 64. Observe that output is shown in two columns. The index is on the left and the data value is on the right. If we do not explicitly specify an index for the data values while creating a series, then by default indices range from 0 through n-1. Here n is the number of data elements. We can also assign user-defined labels to the index and use them to access elements of a series. The following example has a numeric index in random order. Series 2 equal to pd dot series Kavi, Syam, Ravi, index 351. Print series 2. Display the series. Third is Ravi, fifth is Syam, 1 is Ravi. D type object. Here data values Kavi, Syam and Ravi have index values 3, 5 and 1 respectively. We can also use letters or strings as indices. For example, series 2 pd dot series 234 index Feb, M or March and APR for April. Print series 2. Display the series Feb 2, March 3, April 4. D type int 64. Think and reflect. While importing pandas, is it mandatory to always use PD as an alias name? Question mark. What would happen if we give any other name? Creation of series from Numpy arrays. We can create a series from a one-dimensional 1D Numpy array as shown below. Import Numpy as np. Import Numpy with alias np. Import pandas at pd. Array 1 np.array 1 2 3 4 series 3 pd.series array 1. Print series 3. Output 0 1 1 2 2 3 3 4. dtype int32. Data handling using pandas 1. The following example shows that we can use letters or string as indices. Series 4 pd.series array 1 index equal to Jan, Feb, March, April. Print series 4 Jan 1, Feb 2, March 3rd, April 4. dtype int 32. When index labels are passed with the array, then the length of the index and array must be of the same size, else it will result in a value error in the example shown below. Example 1. Array 1 contains 4 values, whereas there are only 3 indices. Hence, value error is displayed. Series 5 pd.series array 1 index equal to Jan, Feb, March. Value error, length of passed values is 4. Index implies 3. Creation of series from dictionary. Recall that Python dictionary has key, value pairs, and a value can be quickly retrieved when its key is shown. Dictionary keys can be used to construct an index for a series as shown in the following example. Here keys of the dictionary 1 become indices in the series. Dictionary 1 equal to India, New Delhi, UK, London, Japan, Tokyo. Print dictionary 1. Display the dictionary India, New Delhi, UK, London, Japan, Tokyo. Series 8 equal to pd.series dictionary 1. Print series 8. Display the series India, New Delhi, UK, London, Japan, Tokyo. dtype object. Accessing elements of a series. There are two common ways for accessing the elements of a series: indexing and slicing. What is indexing? Indexing in series is similar to that for Numpy arrays and is used to access elements in a series. Indexes are of two types: positional index and labeled index. Positional index takes an integer value that corresponds to its position in the series starting from 0, whereas labeled index takes any user defined label as index. Following example shows usage of the positional index for accessing a value from a series. Series num pd dot series 10 20 30 series num 2. Here the value 30 is displayed for the positional index 2. When labels are specified, we can use labels as indices while selecting values from a series as shown below. Here the value 3 is displayed for the labeled index March. Series months pd.series 234, index Feb, March, April. Series months March 3. In the following example, values New Delhi is displayed for the labeled index India. Series cap country pd.series New Delhi, Washington DC, London, Paris, index India, USA, UK, France. Series cap country India, New Delhi. We can also access an element of the series using the positional index. Series cap country 1, Washington DC. More than one element of a series can be accessed using a list of positional integers or a list of index labels as shown in the following example. Series cap country 32, France, Paris, UK, London. Dtype object. Series cap country UK, USA, London, USA, Washington DC. Dtype object. The index values associated with the series can be altered by assigning new index values as shown in the following example. Series cap country dot index 10 20 30 40. Series cap country 10 New Delhi, 20 Washington DC, 30 London, 40 Paris. Slicing.
हेलो पंकज एजुटेक चैनल में आप सभी का स्वागत है। आपसे आग्रह है कि वीडियो को लाइक करें तथा अपने मित्रों के साथ शेयर करें, जिससे कि वैसे भी मुफ्त में ज्ञानवर्धक जानकारी वीडियो के माध्यम से प्राप्त कर सके। चैनल को सब्सक्राइब करिए, जिससे कि आने वाले सभी वीडियो का नोटिफिकेशन आपको तुरंत प्राप्त हो सके। डिस्क्रिप्शन बॉक्स में दिए गए वेबसाइट को विजिट करिए तथा ईमेल के माध्यम से सब्सक्राइब करिए, जैसे कि कंप्यूटर साइंस तथा तकनीकी से संबंधित नवीनतम ब्लॉग आपकी ईमेल आईडी तक पहुंच सके। वेबसाइट में कई ज्ञानवर्धक जानकारियां उपलब्ध है, कृपया उनका लाभ लीजिए। धन्यवाद। Hello all of you are welcome in the Pankaj EduTech channel. You are requested to like the video and share it with your friends so that anyway you can get free informative information through videos. Subscribe the channel so that all the upcoming videos you can get the notification immediately. Visit the website given in the description box and subscribe through email, such as the latest blog related to computer science and technology can reach your email ID. There are many informative information available in the website. Please take advantage of them. Thank you.